Let's take a look at a program that allocates an array dynamically. What does that mean? Previously, up to this point, we have had to specify how many elements we had in an array. So, for example, if we had an integer and we had, call it numbers, we needed to put a number in here. Okay, so if we wanted 100 elements, then we put 100 elements in the square brackets next to the variable. So this is a fixed sized array, and it was determined before we ever compile the program. So we set the size. But as you have seen in some of the videos that deal with the Alabama weather station data, guessing how big an array is can lead to some problems. So how about we let our program figure out how big the array is? And then when the program runs, it will allocate the amount of space that it needs. This is called a dynamic array. So let's look at how we can make a one-dimensional dynamic array. In this program, I'm starting with some code already. So let's look at what we have. I have the init array function that we've used already, and we have the print array function. So those are the same as what you've seen before. And you can see the code down at the bottom. We're just initializing the array to some random numbers between 0 and 100. And then if we want to print out the array, then we also have the same function here that prints out all the elements in the array. I've declared some variables. So we have some unsigned integers, j, k, and value. And I've got a character variable answer that I've set to the uppercase y. Now, I've done that so that we can go through a loop several times. So let's look at this do-while loop. So we have the do-while loop that begins here. And we're going to ask the user to enter how many values we want for the array. So we'll prompt with a cout, how many numbers do you want? And then we are going to read in that value. So we could want 20, we could want 50, we could want 100, we can make it any value that you want. So then, once we know that value, we're going to add code here that will dynamically create an array with that many elements. So it depends on what number we enter as to how big the array is going to be. Then I'm just going to call the Initialize Array function to initialize it, and we'll print out the array. Then at the bottom, I've got this prompt. It says, do you want to make another array? Enter yes or no. And then we'll read in the variable answer. So that was that character. And if the answer is yes, then we'll stay in the loop. And if the answer is anything other than yes, we'll exit the loop. So we will do while the answer is equal to uppercase y or lowercase y. Now remember, once we type in the answer, we also hit the enter key. The enter key produces a \n. So we don't want that to be in the input buffer when we go back to the top of the loop. So this c.ignore method will clear out any remaining items in the buffer after we've typed in the answer. So that's all we have here. That's just our do-while loop. Then we're going to do some more stuff at the very bottom. Now let's add the code to make this happen. So instead of declaring an integer, numbers, and square brackets and giving it some value, to make a dynamic array, we use a different syntax. So let's look at that. So we have another line of code at the top. And notice the syntax here. I'm going to use this asterisk, and I like for my asterisk to go next to my variable instead of the int. So this is going to declare a special thing, which we'll talk about a lot in upcoming videos. And yeah, it's a pointer. Okay, we'll talk about pointers a lot coming up. So this is going to declare a pointer to an integer. Okay, so let's make the let's put that comment over here, and that's not going to do it. Let's try that again. So now we have the comment that we are declaring what's called a pointer to an integer. But don't be concerned about that right now. Let's just look at the syntax. Okay, well, Visual Studio wants to put the asterisk next to the type, so I guess I'm just going to have to let it do that or keep changing it. But anyway, that's special syntax. So instead of declaring number with square brackets and some number, we're going to use this instead. This allows us to create a dynamic array. Now, let's enter the loop. How many numbers do you want? And we will use cin to read in that number. Then we will dynamically create an array of that many elements. So here is a brand new piece of C++ code that will let us do that. So here's the code. And it's not very big, is it? So we have number. Okay, so number is the thing we declared up here using the asterisk. And we're going to set number equal to a new integer. And here is where we have the square brackets. But inside the square brackets, we put the variable value. So whatever number we typed in here, that's going to be used to set the dimension of the array here. And the statement or the command new is a command to the operating system to allocate this much space. So this is a command that executes when the program is running, and that's called a runtime command or a runtime statement. And previously, when we declared a variable with the square brackets up here, then that was executed at compile time, so the compiler took care of it. But now we're going to delay that. We're going to delay the allocation of space for an array until the computer is actually executing the program. Now, that's all we need. That's all we need to make an array that has this many elements. And of course, they're going to be whatever type we put here. If we wanted to make a float, that'd be a float. If we wanted a double, we'd put a double, and so on. Now, we are going to allocate an array with that many values, so we need to initialize it. So now we are going to call our init array function, and then we'll call the print array function to print out the numbers. Now I've added those calls. So we call the function in exactly the same way. So even though we've declared this number using the asterisk instead of the square brackets, we still use it exactly the same way as if we had used the square brackets. So we don't need to do anything special. We still send in the name of the array to the function, and we send it in here to the init array to initialize the data. We send it in here to the print array function to print it out. Now that we've done that, let's run the program and see what output we get. Now let's look at the output. So we bring this over, and the program is asking how many numbers do we want. Okay, so that came from this cout statement up here. So let's answer. Let's just say we want 10. So I enter 10, and the array is generated dynamically with that new statement. Okay, then we initialize and we print out the numbers. So in this case, we just got the numbers, 41 through 64 here. Okay, at the bottom of the loop, we're going to say, do you want to make another array? Okay, so we can answer yes and make a different one. So let me do that. I'll type in yes or Y and hit enter. And then we're back at the top of the loop. How many numbers do you want? Okay, so let's make it 5 this time. So now I have an array with 5 numbers. So this new technique allows you to create an array of any size that you want, anytime that you want. So let's try one more time here. Okay, do you want to make another array? Yes. How many numbers do you want? Well, let's try 20 this time. We don't want it to be too big. So here you can see we've got 2 rows and there are 10 numbers per row. So that's how you can make a dynamic array. Now, let's stop the program and let's go back in, and I'll show you some things that you should do if you're using good programming practice. So we have the do while loop, and we just demonstrated that. So down here, if we do get an answer for yes, we should actually delete the array that we made previously and then reallocate it. Now, the system is going to delete it anyway, so in the same way that if you don't close a file, the system will close it. If you don't do this, the system will delete the array anyhow. But it's a good idea to always do this. So let's add some line of code in here so that if we want to make another array, we'll delete the one that we just finished. And this will also illustrate the delete command. That's kind of the sibling of the new operation. So let's paste in the code to do that. Alrighty, so if we answer yes, then we want to delete the old array. And the main reason I'm showing you this is to show you delete. Whenever you create something with new, then you can delete it with delete. So we will delete and we will use number again. So when we're creating something, we have number equals new, and then it's sort of like a file pointer. When you want to delete it, you delete and you use that pointer. So we'll delete the array and all its contents. Then we will go back to the top of our loop. We'll ask for how many values do you want. We'll make a brand new array, and then we'll initialize it and we'll print out the values. So this then is how you can make a dynamic array. So remember new, and the type, brackets, how big you want it. And if you want to delete it, we can use delete, and then you use the pointer here. Now, before we finish this up, it's also possible to make a dynamic single variable. So let's look at that. Okay, so we want to do just a single variable. So I'm going to print some stuff to the screen. Okay, see out. I can make a single value too, enter an integer value. Well, the way that you can dynamically create a new variable on the fly is the same as we did previously. We can use new, but this time you don't use the square brackets. So if you want to make just a single variable that's an integer, then this is the way to do it. What's the difference in doing it here versus doing it up here at the top like we did with these values? Well, once again, when you declare things up here, the compiler will process those statements and it will make arrangements for the space to be allocated. When you use a new operation as part of your program, then the space for number is not created until you get to this line of code. So the new is going to ask the operating system to allocate space in memory and designate it to be the address of an integer type, or that is, we'll store an integer there. So you can do this for any kind of variable that you want. Well, this just declares it. This doesn't really give it any value. So if we want to read in an integer, then we can use a cin statement to do that. So let's put the code in for that. So here is the cin statement. Now, one thing you have to do when you're dealing with just a single variable, not an array, is you have to use the asterisk down here. All right, so we will do cin asterisk number, so that reads in an integer, stores it in number, and then we'll just print that back out again. Okay, you entered, and then we print out the number, and don't forget the asterisk on the left. So this allows you then to allocate space for just a single variable, and when we're all finished with that, we can also delete it like we did the array. So we could delete it here by doing delete number and semicolon. All right, now let's run the program and let's look at the output this time. Now let's look at the output. I'll bring the window over. How many numbers do you want? So this is the do while loop. So let's put in 10, and we see the 10 generated. And just for fun, let's do another one. Okay, yes, so we deleted the old array. Now we're making an array also called numbers, and let's make it bigger, make 100 elements for this one. So there we go. We've got 100 elements now for that array. So we can continue to delete the array and reallocate it as many times as we want to. I don't want to make another one. I want to move on to the bottom part of the program. So I'll do a no. And then we get the output. I can make a single value too. So we enter an integer value. So I'm just going to put in a number 9. Then when I hit enter, it says you entered 9, and then we're at the bottom of the program. Well, what's happening at the very bottom? One more time. When we want to make a brand new variable, then we can also dynamically do that. Number new int. And if it's only one variable, we have to use the star notation whenever we're accessing it. So we can read it in, we use the star number, and when we print it back out, we have to use the asterisk number. So that's the only difference then between the array, the dynamic array, and a dynamic single variable. Okay, then we delete it and we're done. So that introduces then dynamic arrays as well, I guess, as dynamic individual variables as well. All right, so that's all we're going to do with this video, so we will stop here.